Okay. NVL function returns the expression 1 if the expression 1 is not null. If expression 1 is null, then it will returns the expression 2. Same way, suppose if same example, you can say here instead of the A, I am giving the null here. So what will happen? Now it will go to the output here, that is consider the value expression 2 value. So instead of the null, if I say put the single quotes also, then it is also null also. This is the, for the null you can mention either single quotes or you can mention the null here. Suppose if I am mentioning the null in the single quotes, then to select envelope, null in the single quotes, comma, B also in the single quote, from dual. So what is the output here? So I'm going to get the null only, because whenever it is mentioned in the single quotes, that means if this is considered as a string value. Okay. So whenever you are mentioning the null in the single quote, so that will become as a string value. That means there is a value present, so that it will take this as a value considered here, so that it is giving you null here. Without the single quote, so if you mention null, then automatically this value is null value, so that it will take the B here. Suppose if I say 1, then it will take 1. Here within the single quotes, I am giving 1, otherwise 1. So then it is value it is there, so that it is taking. Now you can say which one it is taking, expression 1 or expression 2. So it is taking only expression 1 because there is a value it is there. Okay. So mention 0, then also 0. So some value it is there, so that it is taking this expression 1. So there is no value, then it is going to expression 2. So now we have one more function, that is NVL2. So this is the NVL function. Now one more is NVL2. Expression 1, comma.
It is also a predefined. Huh?
Yeah, these are all predefined, Oracle predefined functions.
Okay.
So user-defined function will come in the PLSQL. Already told you, no? Last class. Whatever we are learning these functions, every function is from the Oracle predefined only. Okay. So NVL2 means expression 1, comma, expression 2, comma, expression 3. So if the expression 1 is null, it returns the expression 3 value. So if the expression 1 is not null, then it will return the expression 2 value. Okay. Whereas NVL function, what it will have? NVL function have the only expression 1 and expression 2 only. Within this, suppose this value, first value is expression 1 is null, then it will go for the expression 2. But whereas coming to the NVL2, so if the expression 1 is null, then it will go to expression 2 directly, expression 3 directly. So if the expression 1 is not null, then it will take the expression 2 value. Select envelope ABC. So here this is not null, so the output will be B it is giving. Suppose if you take NVL only, then what will happen? There is a invalid arguments it is saying. So because as per the NVL we have the only expression 1 and expression 2 only, then it will consider 2 values only here. If we are giving more than 2, then it is throwing the error. So here NVL2, what it will do? It will have the expression 1, 2, 3. 3 values you have to provide for the NVL2. So if this value is not null, then it will give you the expression 2. If this value is null, then it will give you the expression 3 value. Okay. Suppose n will have a comma, and here I am giving null value, and C I am giving. This is the expression 1, expression 2, expression 3. So here expression 1 is not null, so that it will give you the expression 2 value. But here expression 2 is having the null, so same it will return here. Suppose instead of null, I said 2 here, then it will return invalid number it is saying. Why? Because this data type is mismatch here, so that you can put the single quotes. Then you are getting the 2 here. Okay. Suppose if I am getting null value here and here 3, then it is giving the 3. But whenever there is a varchar 2 data types, then number data type and varchar 2 data type it will mismatch, so that you have to either provide in the number values only here, or you have to provide the all the numbers also in the varchar 2 format. That is, you have to provide the single quotes here. Then only it will work here. Okay. So when this value is present, then it will consider the expression 2 value. When this value is not present, then it will consider the expression 3 value. Whereas in the NVL, expression 1 is null, then only it will consider for the expression 2. If expression 1 is not null, then same value will be considered here. So next function we have the null if. Okay. Null if means if expression 1 and expression 2 return results are same, it returns the null value. Otherwise, it returns the expression 1 value. Null if expression 1 comma expression 2. So if both are same, okay, expression 1 and expression 2 both results are same, then it returns the null value. Otherwise, it returns the expression 1 value. Correct? Null if a comma a from dual. So that is null. So both values are same, so it will return the null value. If I say B here, null if A comma B, then both are not same, then it is returning the expression 1 value only. Suppose if you are having the 1 comma 1 here, then it is returning the null here. Suppose if it is having 10 comma 1, then it will return the 10. Suppose this value is null, then this saying inconsistent data type. Here it is mentioning the null value, so that either you have to mention like this. Right? So you have to, okay. So this value is null here, so that it is written null only. Suppose this value 1 is there and this value null is there, then it is returning the 1 here. Both are not same, then it will return the expression 1. If both are same, it will return the null value. So select null if A comma null, so then it will return the A only here. So using this null if, you can do the arithmetic operations also here and compare this. Select null if 100 comma 50 into 2. comma, null if 200, comma, 15 into 9, null if 600, comma, 300 plus 300 from Google. So what could be the output here? Select null if 100, comma, 50 into 2, that is total 100, comma, 100 it will come, so that it will give you the null value here. But here 200, comma, 15 into 9, so values are different, so that here it will come 200. Again here 600 plus 600, 600, comma, 600, so that both it will make it as null here. So first value and last value null it is displaying, and for the middle value it is giving 200. Why? Because this one is not equal. Both values are not equal, so that it is returning the expression one value. So from our table, so you can see this one more example. Select ename, length of ename. This is the expression one I am taking. Comma job, length of job I am taking the expression two. Null if, length of ename, comma, length of job null if. That is a column alias name I am taking. Null if, length of job ename, comma, length of job. Both are same, then it will make it as a null. If both are not same, then it will give you the ename, length of the ename here. So name, the expression one, that is 4 it is giving. And job, president, and expression 2 it is giving 9 here. Same way 5, 7. So where are the, see this is the Smith it is there, 5 it is there, and job also 5 it is there, clerk. So that it is here, it made null here. Here also Adams 5 characters and clerk 5 characters, so that it is giving null here. James, clerk. Remaining, whatever the expression one value is there, that expression one value it is providing here. So king and president, it is having 4 characters, it is having the 9 characters. So both are not same, so that it is returning the expression one value, that is 4. Next we have the coalesces function. So it picks the first not null value from the given list. Coalesces means it picks the first not null value. Coalesces expression 1, expression 2, expression 3, like expression and numbers will give you within this. So which is the first not null value that will be give the output here. Select coalesces A, B, C, D, E from dual. So here the values are present. This is the expression 1, expression 2, expression 3, like that. So for this expression 1, value it is there, so that it is taking the first value only. Suppose if you are taking only B, C, D is there, then it is taking the first not null value, that is B. Suppose if here I am giving the null value, then also it is going to take the B. Here also I made it null. 2 null values are there, and C, D, E. Then it will go to the E value. Sorry, C value. Suppose if I made it as a null here and B. Okay. So it is coming the first not null value. So first value is null, second value is B here, so that it is considered the B value here. Suppose everything is null here except this last value, then it is going to E only. Now if I say here, E is there. All null values and last E, if I say F also, then it is going to E. then it is going to F. Same way you can use the select policies 100 plus null, 128 minus null plus 1000, comma 12 into null, comma 268, 2120, 3281. So what will happen for this? 100 plus null means total null only. 128 minus null plus 1000 also null. Anything, multiplication, subtraction, addition, everything with the null automatically output also it will become as a null only. So here first not null value means that is 268 because this is also become null, this become null and this will become null. So after that first not null value is 268 so that policies will pick up the first not null value only. From our employee table we have the select ename, comma job, commission into 2, comma salary into 1.5, policies, commission into 2, comma salary into 1.5, bonus from the EMP. So that means here commission into 2 there is a if it comes a null value then it will pick this salary into 1.5. Otherwise if the commission into 2 is not null then it will pick only commission into 2 value whatever it is there it will pick here. So see here these are all null values it is there. Only here value it is there for the commission so that here it is picking 600. Here 1000. So first one not null value it is picking here. So here before that I'll write commission also so that it will be easy. So this is the existing commission 300. Commission into 2 means 600 it is taking. Okay. In the bonus column it is mentioning the policies of commission into 2, comma salary into 1.5. That means here this value is present so that it is taking 600 here. For remaining here null values are there here in this so that wherever the null values is there it is considering the salary into 1.5 that will be 7500 here. Here 4275, 3675 like this. Wherever null value is there, so it is considering the salary into 1.5. So wherever value is there for the commission, that is considering the first value only. Okay. So these are all about the functions, predefined functions. So any doubts here? So next we have the constraints. So next topic we have the constraint topic here. So it is used to controlling the data in the table. Why we use the constraints? So to control the data insertion into the table, we will use the constraints. So it is used to prevent the invalid data entry into table. It is also used to maintain the security of the table. So to implement the business rules or the process of enforcing the business rules on database tables is called the data integrity. There are two types of integrity, okay? One is predefined and another is user defined. That is predefined integrity means constraints. So user defined integrity means it will come under the triggers. So generally Oracle will support the three type of integrity constraints, that is domain integrity constraint and entity differential. So here domain integrity constraint and entity integrity constraint, and last is differential integrity constraints. So what it means, domain integrity constraint. It is nothing, domain integrity constraint, nothing but the column. It ensures that to check the values with the user defined condition before accepting the values into that column. To perform this mechanism, you can use the check constraint or not null and default constraints. Under this domain integrity constraints, you can use the check constraint, not null, and default. So these are the constraints we are going to use in this domain integrity. Okay. Same way entity integrity under entity integrity. So it ensures that the each row uniquely identified in a table. To implement this mechanism, we can use the primary key or unique key constraint. Primary or unique. These two constraints will come under the entity integrity constraints. So next we have the referential integrity. That is, it ensures that the create a relationship between the tables. Okay. So domain integrity, we have the, it will check the whether data is correctly inserting or not, it will verify. So, but entity integrity means it will only for the to identification purpose, whether it is having the unique values or not. You can use the primary key constraint or unique key constraint. Okay. So coming to the referential, so to implement this mechanism, you can use the foreign key referential key, or we can call it a foreign key. Okay, or you can call it as a differential. So that means foreign key means in one table we will mention the primary key column, into another table foreign key column. So that how it will work, we'll see in the next examples. So what is constraint actually? So constraints are used to restrict unwanted data into table. All database are supporting the constraint, that is check constraint, not null, default, unique, primary key constraint, and foreign key. This it will support by all the database. And also we have this constraints on the two type. It will work on the two types, work as a two. One is on the column level, and another is table level. So column level means in this method we are defining constraints on individual columns. So how will you define this? So on the column level, we are going to define the constraints. Suppose if you are giving the create table name, and column name, data type, size we have to mention. And after that, constraint we have to mention. Beside this column name, we are going to mention the constraint name, constraint type. So normally when you are creating the table we'll mention the column names. On the beside that column names, you have to mention the this constraint name. So table name means table level means in this method we are defining the constraints after all the columns are declared. That means at the end of the table definition. So that will be column name, data type size, constraint, constraint name, constraint type. This way we have to define the constraints. Okay. So we'll go with the first not null constraint. It is used to allow only not null values. Okay. When you are inserting the data into the table, when this constraint is mentioned to that column, so it will allow only values. It will not allow null values into this column. It does not allow null values. It can define at the column level only. Not null constraint not supports table level. Column level, how it will define not null. So we'll see the example. We'll create a table, create table xx underscore student underscore not null table name I'm giving like this, and column name s number, serial number, number data type, and s name varchar2 of 20. Here I'm giving not null and is number. Okay. Then I'm going to create the table with this structure, that is serial number, student name, fees. I'm taking these three columns. So out of these three columns, S name I'm mentioning the not null. This is the column level constraint. That means serial number should be in this, while inserting into this table, we have to provide the three values, that is serial number, student name, fees we have to provide. But within these three columns, this is mandatory. Not null means it should be some value should be there, but these serial number and fees, if it is null also it will accept. Okay, so we'll insert some values. Insert into xx underscore students underscore not null values. I'm giving serial number 1, comma, name I will give a, comma, fees 3000. Okay, so insert into this table values I am giving. For the serial number 1, student name A, I am giving fees 3000. Did we create it? Okay, we have not created the table. We are creating the table now. Table is created. So now we are inserting values into this. Insert into XX student not null values 1 A 3000. So first record is inserted. I am going to insert one more record. 2 B I am inserting. Here I am inserting null value here. Second row inserted. Now I am going to insert third row. So 4000 I am giving. So serial number I am giving null here. Equal to null. So now table, how many records are there? Table is having the 3 records, but in this, all the S name is having the value, but in the serial number and fees, it is having the null values. Now I will try to insert another record. I'll give this is 4, and here I am mentioning this null value here. In the name I am trying to give the null value here, then it is throwing the error. Cannot insert into. Okay, apps dot this table name s name is the constraint error. Okay, the object cannot accept the null values. That means whenever you are using this not null constraint for this column, so it is you have to provide some value for this, otherwise it won't accept. So null values won't be accepted for this column now. Suppose if you give the value here, then it is going to accept. Column serial number and fees null I am giving. Only student name I am giving here, then it will accept the values here. See this. Okay. So without this, so if you give the values here, but name value it is not there, then it will throw the error. If you give the serial number and fees, both values are giving, but student name is not giving, it will throw the error here. So that is the constraint, not null constraint. So whenever you are defining this not null for the column level, okay, so you have to provide values, compulsory values for this column. So same way you can give the, here I am giving the not null constraint name only I given. Suppose if you want to give the entire constraint name also, then you have to provide like this. Create table xxemp underscore nn underscore today's 08. So then employee number constraint emp underscore p1 underscore nn underscore 08 I am giving. Constraint name we have to give. So here column level not null I am mentioning here. So on for this constraint name I am giving the some name here. Employee number data type, and constraint name not null constraint I am mentioning here. So table is created. So describe the table. So here see this employee number not null it is coming. Same way if you describe our previous table. Here also S name is not null. Okay. So we'll continue with some of the other examples for this not null, and remaining also will continue tomorrow. Remaining constraints also there. So any doubts as of now? Everyone is practicing the classes. After class, you are practicing the session. Hello.